Cisco Certified Network Associate Day 11. Welcome back everybody, I'm Imran Rafi, your trainer for this entire series. Today we would be discussing about VLAN foundations, and before we go any further I would ask all of you to pause this video, click on the bottom left hand corner which says Networking Consultant and go to our Facebook page, like it, come back and click on the bottom right hand corner which says Networking Inc., which is our official YouTube channel, and subscribe to it. We would be adding many more wonderful video series now we will be doing the CCNA, then we'll be doing CCNA security, we would be doing Network Plus, we would be doing PMP, ITIL, Prince2, and many wonderful series as we go along. So I'm assuming you just paused, you liked my page and you subscribed, right? So thank you so much for doing that. So let's get on with today's class. Today we are talking about VLAN foundation. Today we're going to talk about three things. What is VLAN? Why do we need VLAN? And how to configure VLAN. So at the end of this video, I expect all of you to answer these three questions. And if you can, you have understood this video. Right, what is VLAN? VLAN is the short form for virtual LAN. And why is it virtual? We will discuss that as we go ahead in this video. Before we go into VLAN, we need to understand the working of a switch. We know how the switch works, so we're just going to review a lot of topics that we have already discussed. The first thing we'll discuss is about having multiple collision domains. And we know that this 48 port switch that you see on the screen has 44 collision domains. That means each of those ports or devices connected to each of those ports can communicate with another device on another port without colliding, right? So they are independent with each other. And also we also know that all the 48 ports of the switch are part of one broadcast domain. That means, let me take a pen. That means if the multiple devices connected onto multiple ports of the switch, right? And if one of those devices send a broadcast, so let's assume this guy sends a broadcast, that same broadcast is just sent out on all the active ports of the switch, and that's how switches work, right? We know this. If you want to imagine, it is like everybody sitting in one room, closed room, and if one speaks loudly, everybody in the room can hear, right? So is it an efficient way of having a network? Not really, right? As more and more people come in, the more louder the room becomes, and it becomes very inefficient where nobody can talk, right? Similarly, in a computer, if there are many devices on the same network, the broadcasts are going to be so loud that you cannot have any efficient communication, right? Another thing we know by now is that if one of those devices is in 192, let's assume 192.168.1.0, then all the other devices has to be part of the same network, right? So in a switch should be connected, a normal switch that is, should be connected to the same IP network. Now, the inherent problem with a switch or the layer 2 device is that one device, if two devices are connected in the same network, right? So this guy and this guy, they can easily access each other's computer. So let's assume that we have among us in our company, we have one hacker, right? The bad guy. Now he sits and I'm sitting here, this is my computer. It's very easy for this hacker to get onto my computer because we are part of the same layer 2 network. Now that's a problem, right? And let's assume I'm part of the executive management team and he is just a new user who's just hired, and he can literally get access to my computers, my files, which is not right. So we need to find a way to solve that problem, right? Of course, my computer has its own firewall which can prevent, but still there are many ways of defeating these firewalls because most of the softwares today have vulnerabilities, and somebody who knows much about hacking can very easily hack into the system. And also, the danger of having everybody in one big broadcast domain is if one of those devices malfunction and starts sending broadcasts, it will jam the whole network and all the 48 devices. Let's assume that there's a 48 port switch and all the 48 ports are connected to different hosts. Then one malfunction can bring down the entire network with 48 hosts. That's not something we want, right? So what do? We make use of a concept called VLAN or virtual LAN. Now, to put it very simply, VLAN means breaking down this large 48 port switch into smaller switches, right? That's what VLAN does. It's just like, I think the easy way to think is like subnet. We know subnet. We took a large network, broke it down to smaller networks. VLAN is something similar. We're taking this large switch, right, 48 port switch, and we are breaking it into smaller switches, right? We create, let's say, a 12 port switch, and all of them part of the new joinee network. We take another 12 ports, we put them, all of them part of management. We take another 12 ports, we say all of them part of the IP phone network, right? So we can break down the switch logically, right, virtually, into smaller networks, right? In this case, I have marked 3 ports. So we are assuming that these 3 ports are in the blue network. We call it the VLAN 10, and these red ports are in VLAN 20, right? So any communication or any broadcast that is coming on any of these blue ports will only go to the other blue port. So you get a blue port broadcast that will only go out of these 2 ports. It will not reach any of those other ports. Now, same way, any broadcast that is coming to the red ports, right, will only go out on red ports, right? So will come here, but not in any of the other ports. So this is as if you have taken 2 different switches, right? So VLAN is a logical way of grouping or separating the switches into different networks. So for all practical purpose, it is like these 3. Let's assume this is another switch, and it is as if these 3 blue ports are connected to a different network, and these 3 red ports, right? So let's assume this is, I'm so sorry with my drawing, I don't have my stylus. So these 3 ports are as if it's in a different switch. So basically they cannot communicate with each other. If you want to connect more ports, like let's assume we have 2 buildings, and we have management staff sitting in this building, and we also have management staff sitting in that building, and we want communication, like let's assume the reds are management, right? So we want management to communicate. So I want a broadcast coming here to automatically go in all the red ports, immaterial of which switch it is part of. Same thing happens here. Let's say any broadcast that is coming out of the blue port has to go to all the blue ports, immaterial of which physical device it sits on. We can do that by making this link as trunk, right? We discussed that if 2 switches are connected, it has to be connected as trunk. Now at this point, the question that you should be asking is, what is different from a normal switch and this VLAN switch? There's nothing much difference other than when you take a brand new switch in factory setting mode, all the ports of the switch are part of something called as the VLAN 1, right? VLAN 1 is also known as the native VLAN. So when you take a device out of the box, they already configured, all the 48 ports are configured to be part of VLAN 1, and that is why when you connect a device to one of these ports, they communicate with each other because they are all part of the same VLAN. But the minute we change these ports, we go to these ports and say now you're part of VLAN 10, and I go to these ports and say you're part of VLAN 20, and these are part of VLAN 1, they 3 are now 3 different switches, right? So these without any color, they are all part of the switch. So if I send anything out of one of the ports, it'll all come of the other ports, and these blue are part of another VLAN, and these reds or oranges are part of another VLAN, right? So this is how it works. So effectively what it does, it logically breaks network, it segments broadcast like we discussed, and each of these subnets or each of these VLANs will have to have its own separate network for communication. So if I have a 192.168.1.1 here, or 192.168.1.0 network here, and if you put a 192.168.1.0 network here, in spite of they being same IP address, they will not communicate. Like I said, they are like connected to different physical switches. Of course, physical switches will not communicate with each other if they don't have any link, right? So that's how they are. So you'll have to create different subnets for different VLANs. Now, one thing that you need to understand at this point is that VLAN is a concept understood only by the switch or anybody else who understands the encapsulation protocols like .1q or ISL. But all the other devices like the router or your computer cannot understand anything about VLANs. So now you're connecting your computer to this VLAN, you don't have to make any changes on the computer. Your computer will act as if a normal computer. I mean, just the same configuration that you did earlier. You don't have to make any changes. The changes are happening only at this layer, only in the switch, which is layer 2. Now what it does is the minute you put VLAN 10, VLAN 20 you create, the switch creates something called as the VLAN database. Now switch says switch port 1, 3 and 5, right, are part of VLAN 10, 14, 15 and 18 are part of VLAN 20, and everything else is VLAN 1. Now if any traffic is coming from VLAN 10 or these 1, 3 and 5 ports, it will only be sent to those ports, which is also part of the same VLAN. Similarly, any traffic that is coming from any of these VLANs, any of these ports, I'm talking from perspective of the switch is monitoring which port it's coming from, and it is just looking at the VLAN database and telling that, okay, port 1 is part of VLAN 10, or port 3 is part of VLAN 10, port 5 is part of VLAN 10. Similarly, port 14, 15 and 18 are part of VLAN 20, right? So it is looking at that and it is making sure that it sends out. But the receiving device knows nothing about VLAN. Your computer will never know that it's part of VLAN 10 or 20, right? Now, when we connect two switches, we know that we put that port into something called as the trunk. Now, what does a trunk do? Like we already know, trunk is a Cisco word. Normal other companies like HP, Juniper, they call it tagged port, and tagged port actually makes more sense. Why? Because when any traffic goes out of this network, right? If you're connected trunk, like we know that trunk will send out all the traffic coming on this switch to the next switch. That's what trunk does. Trunk just sends everything. So now it's just like a 48 port switch, and 48 port we're connected. It's like a 96 port switch, right? So when it is sending traffic coming from VLAN 10, it is going to tag. It's like putting a sticker on that saying, okay, this is VLAN 10. So when that comes here to this switch takes that sticker out and says, okay, I know that you are VLAN 10 traffic. That means you will only go out of blue ports, right? Similarly, any traffic coming from the orange port will get tagged VLAN 20 and it will go here and it will only send out of VLAN 20. Anything coming from native VLANs will be tagged with VLAN 1 or native VLAN, and it will only go out of native VLANs in the switch. And that's how it is. Now we also spoke about encapsulation. There are two encapsulation methods. One is the .1 queue. So whenever you make a trunk, you have to give an encapsulation. Now encapsulation protocol .1 queue is an open standard. It's part of the IEEE, and there is another protocol called ISL, or inter switch link, right? These are the two encapsulation protocols. But in today's world, all modern switches use .1 queue, and that is why when you configure trunk in modern switches, you will not even have the encapsulation command, because by default encapsulation is .1 queue. Now when we go into configuration mode, I will tell you what I mean, right? So you have to make your trunk in .1 queue encapsulation, and only then it will be able to read your tags, right? So that's by default. When you're making a port into trunk, it automatically gets the .1 queue encapsulation. Right, now let's get into the interesting bits. Let us try to configure VLANs. Let's create a network. So let me take two switches. That's switch 1 and that's switch 2. Then let us take two end devices. I'm going to say PC1 and PC2. I'm going to take a wire, connect this wire from here to FS0/0, FS0/1, and then FS0/2, right? Right, so we will start with the basic configuration on the switches, right? So let's double click on the switch, go to command line interface. Let us do all our basic configuration. Host name switch 1. What else we need? That's enough for this configuration. I think let's just leave it at this basic configuration. We just need the host name. Now let's go to this computer. We will give it an IP address, so it will be 192.168.1.1. Gateway is not required because we are doing layer 2 only this time. Now we'll go here, IP address 192.168.1.2, no gateway. let me go to this device and I will try to ping the other device 192.168.1.2, and it is working perfectly fine. Why is it working? Like we discussed, at the moment both these devices are connected to ports which is part of VLAN 1 or its native VLAN. Now how do we know that? In Packet Tracer you have this beautiful feature where you can actually see VLAN numbers, so you can see all the ports are part of VLAN 1. But we don't have this liberty in real switches, so what we're going to do is we're going to click on this switch and we are going to go to the user executive mode and say show VLAN. Now what is this? This is the VLAN database. It is going to tell you, now if you look here, it says VLAN 1 and all the ports of this switch are part of VLAN 1. That means you connect to any port, it can talk to each other because they're all part of VLAN 1. So we will change that, right? So we will first create two VLANs, that is VLAN 10. So the command for creating VLAN is just that, VLAN and the number. Here, what are the commands available? You have only no, which is to negate any command like we already do, and give a name. So let's name this as VLAN management. This name is just for your identification. It doesn't play any role in the working of this VLAN, just for identification, right? So we'll create another VLAN, VLAN 20 VLAN, and we can see that we can put any VLAN numbers from 1 to 1005, right? So we say VLAN 20 and we'll name this employees, right? And exit. Now how do we assign these ports to VLAN? So first we'll go to the first port, interface F0/1 switch port mode access. This is manual way of putting this port in access mode. This port is already in access mode, but we'll put this mode in, we'll put the switch port in access mode, and we'll say switch port access, and after that we need to tell which VLAN. So switch port access VLAN 10. So that port has just been changed. So we can see the color here, the color just changed, it's just changed VLAN. Now it'll come back to green, right? And same way we will try this step once again of pinging. Now can it ping the other switch 192? We didn't change anything from the computer's end, from the from the host end. I have not changed anything. This is still in the same 192.168.1.1, and this is 1.2, but it is not working. So see, this has become green now. That means this port has changed and everything is up, but still they will not ping each other because they are part of different VLANs, right? This PC2 or PC1 is part of native VLAN, and PC0 has moved to VLAN 10, right? So let's go back here. Let me put the second port, interface F0/2, switch port mode access, switch port access VLAN 20, right? So now this port will go down and it'll come back. It'll just do what it has to do and put this port in VLAN 20 now. No problem, okay? And once that's done, we can try pinging it again. It will still not ping because they're still part of different VLANs, right? So I'm just going to ping it. It will not work. Even after that becoming green, it will not ping because they're part of different VLAN. So like I told you, this is taking a physical switch and breaking it into two different switches, right? So now it's green and still it will not ping because they are part of different VLANs. Now let's do this. Let me remove this cable, right? And I'm going to take the same PC. I'm going to connect it to this switch. This is a different switch, right? So this switch is now part of FA0/1, right? Of the second switch. And I'm going to connect a wire between these two devices, right? Now if I try to ping from here to here, it will not ping because this is in port native VLAN, that is VLAN 1. But I'm going to do this. I'm going to go to this switch and I'm going to create VLAN 10 here, name management, exit, and I'm going to go to FA0/1, switch port mode access, switch port access VLAN 10, right? So I'm going to put this port also in VLAN 10. So this is in VLAN 10, but in this switch, and there is a trunk that is configured. Oh, by the way, wait, we haven't configured trunk, so we need to do that as well. So this is FA0/2, this is FA0/2, right? This is a bug in Packet Tracer because this was FA0/3, but for some reason it become FA0/2 now. So we're going to change FA0/2 to trunk. So interface FA0/2, switch port mode trunk, right? So you can see that I've changed this to switch port trunk. So this has become a trunk now, trunk. And we'll do the same thing here, this side. We will go here and interface FA0/2, switch port mode trunk, right? Now this is, both of them are trunks now. Now if I ping from here, will it ping? Absolutely yes. This is in VLAN 10, this is in VLAN 10, and this is in trunk. So traffic is going like that and it's pinging absolutely fine, no problem at all. So what it did, it literally made sure that if it is in different VLANs, it doesn't work. If it is in same VLAN, it works. And that's what VLAN is all about. Now we will do one more thing. I'm going to put another device here, and I'm going to put another device here, and I'm going to connect this. I'm going to connect this, right? And let me create these into, let me put this into a different VLAN. So it's 192.168.2.1, right? And this guy is going to be 192.168.2.2, okay? And FA0/3, FA0/3, right? So I'm going to go here, interface FA0/3, switch port mode access, switch port access VLAN 20. I'm going to do that here as well. Sorry, I'm going to go do that here as well. Interface FA0/3, switch port mode access, switch port access VLAN 20. Now, okay, so okay, good we did this here. If let's say you're giving this command, switch port access VLAN 20, and if the VLAN 20 is not created, like we created only VLAN 10 in this switch, we did not create VLAN 20, it will give this error which says access VLAN does not exist, creating VLAN 20. Absolutely no problem. We just created a VLAN for you. If you want to go name that VLAN, so let's do this. So I say show VLAN, and you can see that you have default VLAN, right? And then you have VLAN 10. I have named it management, so name is there, and FA0/1 is part of that VLAN. VLAN 20, I did not name it because it got automatically created. That's why this default name is there, and FA0/3 is there. Like I said, this name does not matter. If this name is different from the other switch, it doesn't matter at all. It only looks at this VLAN numbers. If you want to change this VLAN, all you have to do is go into VLAN 20 and give a name employees, right? Now, in spite of it being, let's say we'll give some other name just to prove that it doesn't, IP phones. All right, sorry, you can't give a, all right? So now I'm going to go here and I'm going to ping 192.168.2.2 and it will ping. So the name does not matter at all. One last thing that I want to tell you is about the management IP. Now, if you remember from our last class, last video, we gave a management IP. How did we give the management IP? We went to interface VLAN 1, right? And we gave an IP address 10.1.1.1, 255.255.255.0, right? And we did no shut. Now that interface came up, and this is the management IP for Yes, it's not the management IP for the whole switch. It is the management IP for, let's go back to the presentation, interface VLAN. So this, like we discussed, these are part of VLAN 1, the untagged one, the uncolored ones are VLAN 1. So when I say interface VLAN 1 and I give an IP address, that's the management IP for managing these interface 1 or VLAN 1 ports. Whatever you do there, that is the IP address by which you can manage VLAN 1. If you want to manage VLAN 2, you will have to create interface VLAN 2 or VLAN 10 in this case and VLAN 20 in this case, and give an IP address part of the network. Now this is 192.168.1.0, this is 192.168.2.0. So interface VLAN 10 should have an IP address from that same range, and that's the only time this device is connected to this ports can access that. And VLAN 20, interface VLAN 20 or the management IP for the VLAN 20 needs to be part of the same network, right? So this interface VLAN 1 that we created here, or management IP that we configured here, this is for the native VLAN. If you want a native or a management interface for VLAN 10 that we create something called interface VLAN 10, right? And we give an IP address. What IP address? We will give the same IP an IP address from the same network. So 192.168.1.10, 255.255.255.0, no sharp. Interface VLAN 20, right? IP address 192.168.2.10, 255.255.255.0, no shut. Now, why do we need that? Remember, like we discussed, now if this device and this device is in 192.168.1.0 network, this device is 192.168.2.0 network, and native VLAN 1, we are giving an IP address, management IP of 10.1.1.1 network. Can this device communicate with this device? You want to connect to this on SSH. Can it communicate? No, because they are part of different network and there's no router in between them to route different networks, right? So for this device to manage this switch via SSH or telnet, it needs to have an access on this switch, a management access in the same network, and that's why we create these management networks, so that this switch can telnet or SSH to this IP address or VLAN 20 IP address, interface VLAN 20's IP address, and do all the changes that it wants through SSH, right? So management IP is specific to a VLAN, right? Every VLAN should have its own management access. I know we discussed a lot of things today. There are a lot of discussions, a lot of theories that we discussed. If you feel a little confused, don't worry, just watch it again. And still, if you don't feel very confident, don't worry, it's very natural, because VLAN is a very complex topic and it's a very, very big topic. We will be coming back into VLAN as we go through this series. Many times we'll be referring to VLANs and you will become a master in VLAN. That's my guarantee. But for now, you need to know what a VLAN is, why do we need VLANs, and how do we configure that on a switch. So thank you so much, and once again, don't forget to like our videos and subscribe to our YouTube channel. Thank you very, very, very much.